So when the user correctly guesses a word, we can see the letters jump up and do a sort of dance. So now let's try and create the same sort of effect in this project. To set up this animation, I'm firstly going to create a bool here in the controller, game 1, and I'll set this to false. And this will trigger true when the game is won, and then also trigger the animation. So down here where the guess word equals correct, we'll set game 1 to true. Okay, cool. So now we know when the game has been successfully won. Now let's set up our animation. Now similar to before, let's also set it up in its own stateful widget, and then we can wrap around the widget that we want to animate, which will be the grid tile. So in animations, I'll create a new file and I'll name this dance. I'll create a new stateful widget named dance. Import material. Firstly, I'll create a widget, name this child, and this will be the widget that we animate, and this must be passed in, required this.child. I will also create a bool similar to before, name this animate, and this will trigger the animation when this is passed in as true. Awesome. Then down here in the state class, let's create an animation controller to run this animation. I'll use the late keyword because we'll initialize this in the init state. Whenever we have an animation controller, we should also sync that up with a ticker. So in the state class, I'll write with single, and then I'll select here single ticker provider state mixin. Now in the init state, let's initialize the controller. vsync should be set here. I'll pass in this to sync up the ticker with the controller. So that's all done. We also need to pass in a duration for how long this animation will run. Let's pass in 1000 milliseconds, but we can update this as we need, and I'll right click and add the const. Okay, cool. I'll use the dispose method and then write controller.dispose, so we're disposing of this controller when we no longer need it. Cool, so we have our animation controller set up. Let's take one more look at the animation, and this time let's look in slow-mo. Okay, so we could see the widget animate up about halfway into the next tile, then come back down, and then come up again, but at a smaller height, and then come down again. And all the tiles seem to have a domino effect, where one animation starts, and then before it's finished, another animation starts. So let's create an animation object to make this animation, and this time type offset. And that is because we want to move the widget, we want to offset the widget from its current position. I'll then set the animation equal to a tween sequence. So here we'll use the tween sequence class again, which will allow us to have a series of tweens to chain them together to create a more complex animation. So this will be perfect. So here we write in a tween sequence item. So we need 4 of these. The first one tweens up, the next one tweens back down, and then that repeats itself but with a lower value. So let's create the first one, and this takes in a tween and also a weight. So how much should this tween run in proportion to all of the animation? So here let's pass in our tween, and I'm also just going to pass in offset here, not double like earlier. Okay, so let's create our tween. So the first one begin, and then we also have an end. Offset, so we begin, the first value is the X and the last value is the Y. So we want to start off at the current position, and then the end value, we create another offset. X will always be 0. We're only going to move on the Y. Let's go up 0.8. And this one, I'm going to give this a weighting of 15. So we've created one tween sequence item. Let's copy this and paste this again. Now we're at 0.8 offset, so the widget's moved up by 80% of its height on the Y-axis. So we want to come back down. So first we must set the tween at the same position, and then this just comes back down to 0, so back to no offset. Now we want to repeat this process, so let's copy these two, paste it, but this time let's make this smaller. Let's make this 0.3, and likewise it comes down from 0.3. Let's also make this weighting smaller. I'll make this 12 and make this say 8. So we see when it goes up, it comes down a lot faster. So I'll also set this one at 10. Cool, so we have 4 tween sequence items linked together, which will tween this widget on the y-axis 4 times. Now to get this to run, we'll call .animate. Now we can pass in a curved animation, so we can provide some curves. And we'll pass in the controller here to the parent. Now let's set a curve. So here we've got heaps of options. Let's go with ease and out sign. Okay, cool. So we've created an animation which will create a series of tweens. Now that we have this set up, let's actually set up the animation. So firstly, I'm going to replace this container with a slide transition, which is an animation widget, which will do most of the work for us, similar to the scale transition, which we used before. And here I can just pass in the animation. So this animation will animate our object on the X and Y axes. And in our case, we just want it to animate on the Y axis. And then we also need to create a child. And we'll animate the child that's passed into the stateful widget. So that'll be the grid tile. And last step is we need to trigger this animation. So similar to before again, did update widget, we can use this method on the state class. So we can write if widget.animate. So if animate is passed in as true, up here, this did update widget method on the state class will automatically run and also call the build method. So here I can write controller.forward. And lastly, we want this animation to run after the first animation of the grid tiles flipping over. So if we look at the tiles, each tile has a delay of 300, so the maximum delay is 1200, and this animation runs for 300. Therefore, we want this to run at least after 1500 milliseconds. So let's use a future to create a delay, the delayed method on the future. Let's put in say 1600, so a small delay. And then a method will be run after that delay. Cut our controller, paste that in, and also add the const modifier here. So after animate is true, we'll have a delay of 1600 milliseconds, then the controller will run the animation. Now let's go to our grid, and here we have our bounce animation. Let's also wrap this with our dance animation. So it does not matter which order these are in. This also requires an animate. So we can use pretty much the same logic here. Ball, animate dance. Cool, so we've got ball, animate dance set to false. And we'll pass this in here. Import the library. Okay, so we now need to set this to true. And we want to set this to true when the game is won. So if notifier.game1, so game1 is that variable we created in the controller, and we're accessing that by using our consumer. In that case, animate dance turns true. Cool. Okay, let's run that and see how it looks. Okay, so we have an animation of things moving up, but we also have all of the grids moving up at the same time. So we need to just have the correct word animate, and we also need a domino effect. And also there is a slight delay with the tiles flipping over. And firstly, that slight delay, that is being caused by this current row. So here, current row should be outside of that bracket. And that's because the animation that flips these widgets expects current row to be incremented. Now back in the grid. So firstly, we just want the correct word to animate. We don't want all the grids to animate. We can do that by using a loop, and we'll loop through the tiles entered list that we have in the controller, which has a list of all the tile models which represent all our grids. So we can just write for int I equals, and to access that we use notifier tiles entered dot length -5 I is less than, so here notifier tiles entered length and then I plus plus. So essentially this will just let us loop through the last 5 entries in tiles entered, which will be the correct word. And then for each one we'll say if the index of this specific grid is equal to I, so is this grid one of tiles that should animate, and here we can set animate dance to true, and then this should also be in the same bracket. Lastly, let's create a domino effect. So we want to create a delay for each of these widgets based on where it is in the word. So the first letter should have no delay, but the next letter should have a greater delay, and so on. So let's go to our dance widget, and I'll create one more variable of type int, and I'll name this delay, and this must be passed in. And then here we've set our delay at 1600, so we've hard coded that in at 1600, but instead let's actually use the delay that's passed in, and I need to remove the const there because this is a variable that can change. So here we're going to pass in a different value for each of these grids, which will give it a domino effect. Now back in the grid we need to pass in our delay, so let's create one more variable, int. We'll name this dance delay, and we'll set this initially to our minimum delay, which is say 1600, and now we just need to increment that for each of these grid tiles. And then here we'll write dance delay plus equal, let's say 150 milliseconds, which gives a short delay, so it means the next animation will run when the first one hasn't finished, and then we could times that by the index, and then we'll then pass that in here, dance delay. Cool. Now this I needs to always run from 0 to 4, so we need to adjust that like we have previously. So we'll go I minus notifier dot current row -1, so we'll start at 0 times 5. So basically this is the same logic we've used before. It's just going to reset I to always run from 0 to 4. So we just care about what position the grid is in the row. We don't care about what row it is. Now let's give this a whirl. Let's type in pizza. Okay, cool. So we have our dance animation. Now let's try do that on the next row. So I'll type in an incorrect word. Tiles flip over. Cool, so we have a dance animation. The timing is looking pretty good. Now let's see how that looks against the actual animation in Wordle. Okay, cool. So a fairly similar animation has been replicated. I think we could play around a bit more with the timing, the curves, and also the value of the animation. But at the moment, I think we've got pretty much the same idea. And now let's move on to the next stage of the project. In the next part of this project, we'll start creating a statistics box that pops up at the end of the game using an alert dialog.